Welcome to Super Science with Tina. This virtual enrichment has been brought to you by Center for Success. Okay, so I'm trying to come up with some more interesting things that kids will enjoy and easy for them to do at home without supervision, because there's nothing that can cause any harm. Maybe make a mess, but make sure you clean it up, okay? So, a kid-friendly activity and experiment is best paper plane. So question, what design paper airplanes are best for distance? That's our first step in our scientific method. Second step is hypothesis, our educated guess. I think a skinnier design will fly the furthest. That's number 2 in our scientific method. Gather materials. All you need is 8.5 by 11-inch paper, just like in a notebook, and a measuring tape to measure the distance. That's the next step in our scientific method. And conduct experiment, the best part, just do it. So I may do the next experiment on how to make these. So I did a lot of practice. I already knew how to make this one, which is called a dart, I found out. This is called a dart paper airplane. So I made the 2 most popular types of paper airplanes. This is called a dart, which I guess you can probably figure out because you launch it like a dart. It's pointed at the tip like a dart. So this is a dart paper airplane. And like I said, all you need is some 8.5 by 11 paper and a measuring tape so you can measure the distance. Second airplane, and also very popular, is a glider. It's called a glider because it's kind of rides the air. Okay, and it has, you can see with the glider, you can already tell there's a significant difference between the 2 paper airplanes, right? So you got the dart and the glider, and thinking about what our conclusion and outcome is going to be, think about the shapes of these airplanes and how it may affect the distance that it goes. Okay, so we're going to stay inside, and I put this as part of my data. We're going to stay inside and do the experiment so that the variables, and variables are like the conditions in which you do the experiment. To be fair to both airplanes, we can't do this outside, because if we did, we might get help from the wind. The wind might pick up and pull this one further. It might slow down, and this one won't have any air to ride, okay? So we want to make sure that the variables are conditioned and controlled. So that's why we're inside, so that the airflow is the same, because obviously we don't have the wind interacting inside, okay? So we're going to try both styles and see which goes further. Do you have an idea which one you think will win? If you do have an idea, please think of the reason why. Why would you think the dart would go further? Or if you pick the glider, why do you think the glider would go further? Okay, so We have our dart. And we have our glider. And now we are going to find out which one goes further. So I'm going to turn the camera so you can see that I'm launching the planes. Miss Tina doesn't have a very big place, so I'm going to launch it towards my bathroom. I opened up the door, and then we'll measure the distance. So here we go. First is the dart. Well, that wasn't a very good aim on my part. I'm going to try it again. Okay. Cody, please leave the airplane. We're doing an experiment. Thank you, sir. Okay. And now we're going to do the glider. And Cody is very interested. Oh, wow. That was pretty cool. Okay. Now I'm going to take the tape measure and I'm going to measure. So I was standing right behind the computer. So I got to make sure I pull it. I start from the airplane. Oh my goodness. You're not going to believe this. Let me bring the camera. They landed pretty much in a tie. Okay, so I think the glider made it maybe a half an inch more. So we have 12 feet and 6 inches for the dart. And the glider just made it a tad past that, 12 feet and 7 inches. So it was pretty close to a tie. So in our results, in our data, we would write this down. 12, 6.5, 12, 7. 12 feet, 6.5 inches, 12 feet, 7 inches. And then we would analyze. We tried the two styles. The dart is skinny and pointy, and the glider has a longer wingspan. And then we have our results right there. Just jot them down there in the corner. If you were doing this for an experiment, you would want it to be a lot neater, especially if it was for like a science fair. And then you share out your results. Okay, so what we just did is called aerodynamics. And aerodynamics is a branch of physics that deals with the dynamics of air as it interacts with a solid object, such as our paper airplane. So we just studied physics, which is math, which is science. The glider paper plane flies slower and longer and went a tad further. So those of you who guessed glider, you win, but not by much, because it was only a ½ an inch difference. And the world record holder for the furthest flying paper airplane is 226 feet. And it has not been broken since 2012, 8 years ago. So I challenge you to try your own and see if you can break the record. So thank you all for joining us today and sharing your time with Center for Success. We are grateful for the opportunity to be a part of your life. It's great to share a new form of community with you. Thank you. And if you want to find out more on how to make these paper airplanes, comment below and go on our Facebook page, Center for Success, and ask me, and I'll make that another edition.